Many students ask me whether I could make a video about balancing chemical reaction. So you can see in number one, we have reactions between sodium and oxygen to give you sodium oxide. Yeah, so sodium oxide is actually alkaline, so it is actually base if you add water. Now, the thing that you need to do is you check the number of each atom that you have on the left-hand side, and you match the same number of atom on the right-hand side. So here we have discrepancy in terms of number of atom in number one. So we have sodium on the left-hand side is actually 1, on the right-hand side is actually 2. So we have also 2 oxygen on the left hand side and 1 oxygen on the right hand side, so it is actually in balance. How to balance? So first and foremost, I just need to check whether I have a same number of sodium, because sodium is different. So I put here is actually 2, okay, and then it's already balanced the number of atom that we have in sodium. So if it says that Na2O, it means that you have 2 atoms of Na, and then you have 1 atom of oxygen. So here you only have 1 atom of sodium, therefore we can actually put the coefficient 2. All right, so oxygen is actually 2, and here is actually 1. So how to balance? So we need to actually to put here 2. But if you put 2 here, right, on the right hand side or on the product side, it will change the number of sodium atom. So this is how you read it. If it's written 2Na2, it means that there will be 4 atoms of Na, because initially, right, you have 2Na, and then this coefficient will multiply the number of atoms. So 2 times 2 equal to 4. So 4 atoms of Na. Now it will not be matched with the one that we already written here. So instead of writing 2, so I can change this one into 4, because 2 times 4 is 4. Okay, that's how you do it. All right. Next, number 2 is actually the compositions of sodium sulfate to give sodium oxide, sulfur dioxide, and oxygen. How do we balance this one? So first and foremost, we can see that we have a 2 sodium, 1 S and 1 S, and then you have 4 oxygen. So you have you can count here. This is 1 oxygen here in N2O, 2 oxygens in SO2, and 2 oxygen in O2. So total number of oxygen on the product side is actually 1 plus 2 is 3, 3 plus 2 is 5, but then here you have only 4. So the empirical way to balance that one, we can actually put half. So half times 2 is actually 1, plus 2 is 3, plus 1 is 4. So it's already matched with the number of oxygen on the left hand side. But then usually we don't use fraction on the chemical reaction. In some books they put half the fraction, but for this tutorial session I use I wish to remove the fraction. So what do I need to do is I multiply both sides by 2, because half times 2 is actually 1. All right, having said that, so I can actually multiply all by 2. So I can erase this one. Now I have here is actually 2, right? And then this is 2, and this is 2, and this is actually 1, right? So I don't need to write 1. Okay, so I just write here 1. Okay, so before you finish checking the reactions, please check the number of atoms. So 2 times 2 is 4, 2 times 2 is 4, so already balanced the number of sodium. 2 times 1 is actually 2, 2 times 1 is actually 2, balance. So 2 times 4 is actually 8, 2 times 1 is actually 2, plus 4 is 6, 6 plus 2 is 8. So it's already balanced. All right. Next, let's jump to number 3. So it's actually the reactions of hydrocarbon, because we have a carbon and hydrogen only in the molecule, reacts with oxygen to give CO2 and water. Okay, so here you have 8 oxygen, then you have also 8 oxygen on the right hand side. Now you have 18 divided by 2, so it's actually 9. That's how you do it. All right, and then this is actually 16. Yeah, so number of oxygen is actually 16 plus 9. Okay, so this is actually 16 plus 9 is actually 25. All right, so this one will be 25 over 2. Okay, so 25 uh, over 2 times 2 is actually 25. But again, we have to we try to remove the fraction. So what we need to do, we multiply the coefficient on the left and on the right hand side by 2. So having said that, I'll just put here 2. All right, and then what we need to do is actually I multiply this one by 2, so I have 25 O2, and then this one becomes 16, and this one 9 times 2 becomes 18. All right, so this one is 18. All right, next, it's actually a bit mathematical algebraic when we do number 4. All right, so okay, so what we need to do in number 4, we have xc on the left hand side, because on the right hand side we have 1c, so we may assume that this is actually x. All right, okay, so this is actually y on the left hand side, and it's actually 2 on the right hand side, so I can put here is actually 2. Okay, so 2y, and then I also put here y. So 2 times y to y, 2 times y to y. So it's actually balanced. However, it will change the number of carbon. So here the carbon becomes 2x. So I'll just put here 2x. Okay, so 2 times x, 2x, 2x. All right. Now, how about the number of oxygen? All right, so the oxygen here is actually 2x times 2 is 4x. Y plus times 1 is actually y. All right, so total number of oxygen on the right hand side is 4x plus y. So this is actually 2. So how to balance that one? So I'll just put here, okay, 4x plus y divided by 2. Because when I multiply by 2, then it will give me the same 4x plus y. All right, so the coefficients for this hydrocarbon is 2, coefficient for this oxygen is 4x plus y, and coefficient for the CO2 is actually 2x, coefficients for water is actually only y. All right, next, let me clear up this one. All right, so next, number 5, write equations for mixtures of diammonium hydrogen phosphate by reactions between ammonia and phosphoric acid. So how do we do this one? All right, so as you know that ammonia contains nitrogen and hydrogen. All right, and then when we add to phosphoric acid, then it becomes diammonium. Ammonium, we have a 2 because di. Okay, di is actually 2, tri, 3, and then so forth. So we put here is actually 2. And then phosphate is actually PO4, right? Okay, sorry, hydrogen phosphate. So actually we have HPO4, all right? Because phosphoric acid is actually H3PO4. Then we have a dissociations for this one. It becomes H plus and H2PO4 2 minus. So, and then the second dissociation will give you HPO4. All right, so how do we balance this one basically? So it is actually obvious that the number of nitrogen is actually 2. All right, so when you have this kind of NS4 2, so this is how you read it. So you have 2 nitrogen, and then you have 4 times 2 of hydrogen, so 8 hydrogen. That's how you read it. All right, so don't get confused with this nomenclature system. All right, so you have 2 nitrogen, so you just put 2 nitrogen, and then how about hydrogen? Let's check. So we have 6 hydrogen. 2 times 3 is actually hydrogen. So and then 6 plus 3 is actually 9. So you have already 4 times 2 is actually 8. 8 times 2 plus 1 is actually 8. So 8 plus 1 is actually 9. So actually balance already. So we don't change anything with a number of phosphorus and oxygen. So basically it's just the same. All right. Next is, so the answer is basically this one. All right. So the answer is um, 2NH3 plus H3PO4 to give NH4 and HPO4. Okay. Next is number 6. Sulfuric acid is important chemical with a variety of uses, right? So it says that um, the first stage of which involves the conversions of sulfur or such as galena or PBS into sulfuric or sulfur dioxide. Okay, write the equations for the reactions between galena and oxygen to form sulfur dioxide and lead oxide. So what we need to do here, we can actually generate PBS, all right, plus PBS plus oxygen, so O2, to give PB2. So PB2 plus, and then O is actually 2 minus. So sometimes students confuse how to write the chemical formula for the transition method like this one. So you just move this one diagonally. So you have PB2O, PB2 and O2, but then we need to simplify. So you'll have PBO. All right. Okay, so I'll just erase this one, and then I'll just write here PBO. Okay, so PBO plus sulfur is actually 1, di is actually 2. We have oxygen, so sulfur dioxide is actually SO2. So how do we balance this one basically? So what we need to do is you need to find something that's very different, really different on both sides. So you have 2 oxygen here. Here you have a 1 plus 2 is actually 3. So it's absolutely different. So what we need to do is actually, we can actually put here, here is actually 2. All right. And then if you can also put here 2. So now you have 2PB, 2PB, 2S, but this is actually 1S. So I'll just put here 2S. All right. And then 2 times 2 is 4. 4 plus 2 is actually 6. So 6 divided by 2 is actually 3. All right. So that's the quickest way to resolve this equation. All right. Now, how about last one? Is actually we have this carbide. Carbide is actually one part of the ceramic. So Al4C3 reacts readily with aqueous sodium hydroxide. All right. So Al4C3 plus NaOH. The two products reactions are, so this one NaAlO2 plus CXHY, because we don't know yet the hydrocarbon, right? Water molecules are involved as a reactants. So the position of reactant always on the left-hand side. All right. What's the formula of hydrocarbon? So first and foremost, we need to check the number of aluminum atom. All right. So here you have 4. Okay. So you have 4 aluminum. So I'll just put here 4. Okay. So it means that I have the same aluminum atom already. All right. So actually this is, let me fix this one. So this is actually Al. All right. So 4Al, 4Al. So how about the number of carbon? All right. So here you have a 3 carbon. So I don't really rush myself to put here 3 because I need to check the other thing. All right. So what if I put here 4, because I already balanced the number of aluminum. So 4Al, and as a result of putting 4 in the front of NaAlO2, so I have to balance this one also as 4. because I will already balance Na and Na. All right. Now, of course, I need hydroxylase one. I need to balance, right? So if I think that this one is actually oxygen, so oxygen is actually 4 times 2 is actually 8. So 8, and then I have 4 already from NaOH. 4 times 1 is actually 8. Okay, so 4 times 1 is actually 8. So I need 4 here, logically. So because 4 times 4 equal to 8. All right, so it means that I will have 4 molecules of water. All right, so how to balance this one? So I may think that I have already balanced the rest, but then the question is how to balance the number of carbon. All right, so I don't want to uh, so let's say let's count actually. So now I have how many number of hydrogen on the left hand side is actually 4 plus 8, because 4 times 2 is actually 8, so 12. But then this one is actually something, right? So um, it is impossible to put 12 here. All right, so instead of saying that, so I would say that this one could be CH4, right? So CH4. Why? Because when I put CH4 here, so to balance the number of, why I put CH4? Because when I put 3, so there will be 12 hydrogens only, which is matched with the one that I have on the right-hand side. But then it's also matched with the number of carbon that I have here. So I have 3 carbons, and then I also have 3 carbons there. So I already balanced this fraction. So the conclusion is actually I have 1 ALO4, C3, 4 NaOH, 4 water, 4 NaAlO2, and then I also have 3 molecule of methane. I hope you enjoyed this learning. Thank you so much. Please like and subscribe. Thank you.